So today, before we discuss about the sorting on shared memory model, we want to discuss, because one thing what we observe that all the algorithms what we covered, they are based on the merging algorithms, right? Biatoric merge and odd even merge and other things. So here on shared memory model, the biatoric merge may not give you the, or will not give you the good results. So we'll be discussing merging algorithms on shared memory model. Now, first we'll see that CRCW model, and then we'll see how to write an efficient algorithm on EREW model. So if we can cover both these two algorithms today is good, otherwise also at least we'll try to finish this one and some part of this. Now one issue has to be taken into account while on shared memory model. That issue is nothing but that load balancing of each process. Each process should be busy as far as possible, otherwise you will not be able to achieve the cost optimality. Now let us assume that there are two sequences. One is sequence A1, A2, AR, and another sequence is B, B1, B2, BS. And these two sequences are sorted. They are sorted sequence. So your problem is to merge A and B to get the sorted sequence C. So size of C is 1 to R plus S. There are, you assume that there are n processors, and you should try to design an algorithm which takes this much time. What shall I write here? This time of cost, not a time. So what we should write here? We should design an algorithm such that the cost of the algorithm is R plus S, so that it becomes the cost optimal, right? So this is your problem fix. Now let us go back to the sequential algorithm first. First one is that you know merging of two sequences, right? Sequentially, right? This is known to you, that you take one element of A sequence, another element of B sequence, compare it, then the smaller one you put it in C, and then the element you have selected, you move the index of that sequence by 1 and then continue till all the elements of one sequence exhausted, and the remaining elements of the other sequence you bring it to C sequence. Right? Then you also know the algorithm which is known as binary search. right? This algorithm is, these are the prerequisite of designing the new algorithms. This is known to you, which takes log n time, right? Now, what is the aim? Aim is that you have the two sequences A and B, and you have to divide these A and B in n groups, into n groups, such that one processor can be employed to merge this, the other processor is employed to merge this, and so on, right? And to see that the number of elements it is merging is of the order agreed or not? So that this should be of the order also that every processor is equally busy. Now that means your main target is to obtain these points. So in order to do that, first what we are doing, that the sequence A, instead of, because it contains the R elements, instead of handling with the R elements, you need to find out this point. So you divide this A into n groups. You divide A into n groups, B into n groups, and so on, right? And these n groups, but suppose if I divide exactly n groups of equal size, the problem you will be facing, even if you can merge this, that may not give you the sorted sequence, because this element may be larger than these elements and so on. So exactly this will not help you. So what you have to do, first you assume that these are estimated. Let us assume they are equally likely. So you can divide into n groups. N groups means you need n minus 1 points to get the n groups. And these n minus 1 points, now these points have to be manipulated so that if this is the position, then this should be shifted by this or this side, so that this element becomes smaller than this element, but this element is larger than this, using the binary search technique. That is the idea. So that the cluster which is to be sorted or merged by the processor I, so we have to divide into n groups. So if I fix this one, the other one I have to select from this group in such a way that this element is smaller than this element, and so that I can get the cluster that the processor can be employed to merge this one, right? So next element may be this one or this one. Suppose I select this one, so I have to select an element from here in such a way that all those elements are smaller than this one. That is the idea. And then try to put the cluster in such that the size becomes little larger and the processors are reasonably busy or equally busy. So in order to do that, first we initiate that we divide this into n groups. So in order to get the n groups, you need to get n minus 1 points, right? So because first point is known, if I know these points, in order to get n groups, you need n minus 1 points, right? So I can write for I equals to 1 to n minus 1, do in parallel. I dash is so basically I get this elements. So this is your A and this is your B. So A1 dash is your this element, A2 dash is the next element, and so on. This can be done in constant time. Every processor finds that value, P1, P2, P3, and right? PI finds. So every processor finds one value which takes constant amount of time. Now let this form one sequence is A dash, which is A1 dash, A2 dash, AN minus 1 dash. And B dash is another sequence, B1 dash, B2 dash, Bn minus 1 dash. So now we are merging these two sequence, A dash and B dash, each is having size n minus 1. So I am merging that and we generate a new sequence 3 tuple this, B1, B2, B3, B2n minus 1, 2n minus 2. Now Vi is the 3 tuple thing. So this one is the element. Element means it may be AI dash or BI dash. Then this one gives you the I index, and this one contains the information whether it is A sequence or it becomes to B sequence. Is it okay? This first one is the value of the element, second one index of the element in A dash or B dash, right? And this is third one is telling whether it is the family of A or it is the member of B. This is clear?
So what is the need of A and B last? I mean,
oh, see, say for example, I get 3, 7, 9, and this is your A dash sequence, this is B dash sequence, 4, 6, 8. Now, I want to merge this. This merge will give you 3, 4, 6, 7, 8, and 9. Right? Now, these 3 will not be known to you whether you got it from first sequence or got it from second sequence. So, what I want to try here, 3, 1, A, 4, 1, B, 6, 2, B, 7, 2, A, 8, 3, B, and so on. So that you, by seeing this element, you can find out what is the index of that element, and index of the element with reference to A dash, not with respect. Because if I know the A dash, I know the with reference to A also by multiplying this factor. Now, how to implement this? For this is implementation part. For I equals to 1 to 10 minus 1, do in parallel, Pi gets the smallest or gets Pi uses binary search on B dash to get the smallest j such that right. So what happens that this is your A dash sequence, this is your B dash sequence. Now this element is known to you, that AI dash. Now you are finding the smallest j using this is sorted sequence, because this is a, so you can do the binary search, and AI dash is less than this. So if such a j exists, then V I plus j minus 1 is AI dash I A else V I n minus 1 is equals to AI dash I A. Right? This will occur if there does not, all these elements are smaller than this. That means n minus 1 elements plus I minus 1, that many elements are smaller than AI dash. So, so the position of AI dash will be I plus n minus 1. Agreed? It's a simple binary search, and then you are inserting in V. So this is the first part. This has been done with reference to A. Now you do it with reference to B. So this is 2.1 say. So 2.2 will be PI uses binary search on A dash to get the smallest j such that bi dash is less than aj dash. If such a j exists, then vi plus j minus 1 is bi dash ib, else vi plus n minus 1 is bi dash ib. So you got that merging of two sequences A dash and B dash. Now once you know V sequence which contains the information like that, maybe A1 dash 1, A, then maybe A2 dash 2, A, and like that. But you cannot use this information just like that. What you have to do now, you have to now partition it. What is the starting point and what is the end point, that to be done. Now starting point you can get from here, end point has to be determined from the other sequence. That's how, say what you are getting now. This is one original sequence, from there you got these two sequence. Now this element, suppose you decide this element, now you have to determine from the original B sequence, what should be the B element, so that you can start your search merging zone. Is it okay? So if I know this element is here, corresponding elements I can find out here by multiplying r plus corresponding r plus r by n times. Right? Suppose it is the second element, corresponding element is nothing but 2 into r by n. So this element is known to you. And now using the binary search of these elements with reference to this, you will be finding a corresponding element here, which is the smallest element larger than this element, so that you can start merging this part. Right? This element, starting element is known of A. In order to get the starting element of B, you will be using the binary search on this element, this part. So you will be getting the starting element. Similarly, you will be getting by another process starting element and end part, starting element of A and starting element of B. So you know that you have to merge this part only, because this part has been taken care by other process. Right? Now you have total 2n minus 2 elements in V. Right? So, and one element is known to you. Starting element, first processor things is 1, 1. This is the starting element of A, starting element of B. This is known to you. And now you have to determine the remaining n minus 1 points, so that each processor can be employed to do the merging. So you know the starting element, say Q is your starting element position, so this is known to you, it is a 2 tuple. Now you have to find out the remaining n minus 1 points. So for I equals to 2 to n, do in parallel. If V2I minus 2, every even index V I am taking, because there are 2n minus 2 points, I have to get n minus 1, so I am taking the all even index value of V. If this is nothing but AK dash K A, then X is nothing but K minus 1 Is it okay? This is clear, right? This X is nothing but this is the correct thing?
Yes.
This is cluster of K by R by N. So the position of this will point to K into R by N, or if AK equals to K into R by N. This is K into R by N. Right? So that is the index you got for A sequence, original A sequence, and to get the elements which is the larger than X, larger than AK, in order to get that you will be doing PI uses binary search on B sequence to get the smallest J such that Bj is greater than AK dash. Right? Bj is greater than AK dash. Right? So in that case, you can define your Q2, Qi by X, J. So you observe that you got the starting index of A and the starting index of B. Agreed? Else you will be writing here x equals to, else means what? This is bk dash kb and pi uses binary search on A to get the smallest j such that Aj is greater than bk dash, and you will be defining your qi is equals to jx. So what it did basically, he has found this element and this element's position. Similarly, this is P2 has done, similarly P3 has also obtained, and similarly N also, Pn also obtained this. Agreed? Now you employ this process, P1 process, to do the merging of this, P2 merges this, P3 merges this, and so on. Then you get the sorted sequence. So if I know the starting index, here x and here y, what it means? If the index of A for a processor P2 is x and y, what it means? There exists x plus y minus 2 elements, x minus 1 element smaller than this, and y minus 1 element smaller than this. So if I merge this, what will be the starting index of this? See, this gives you the guarantee x minus 1 element this side. This gives you the y minus element this side. So this starting index for this will be x plus y minus y1 onwards, minus 1 onwards. You will be storing it, right?
Yes.
And how long you will continue? Till either that element exhausted the sequence, or this you encounter to this one of these elements, right? Because if you encounter this element, because this part has been taken into account by another processor, so you don't have to do that. So that is the idea. So the next part is that how to merge it. So for that, for I equals to 1 to n, do in parallel Pi checks Qi. If Qi is x, y, then Pi starts merging sequentially starting with ax of A and by of B, and continues till either there does not exist any element in A and B, or it encounters with the first element So it either there does not exist any element in B for merging, or it encounters an element Ax or By which is larger than or equal to the first component of V2I, because V2I's first component is one element which is a member of this X and Y of the another process. So first shall I analyze, and then let us first determine the time complexity, and then we will see that with the help of one example how it works. Now first one is that in the step 1 what you have done, you have divided into n-1 groups which takes order 1 time. Then second step, so first step is order 1. What is the second step? That you are doing the binary search on A dash, on B dash, and the size of the B dash is size of B dash is n. So log n time, and again you are doing on A dash sequence, which is again log n time. So this is the step 2. Now in the step 3, you are doing binary search on B, right? This takes constant time. You need binary search of B, and it takes, you have to have S elements, so log S time. If it is not the case, you will be doing the binary search on A, which is log R time. So this is not known which one you are going to select. So either this or this, one of them. So larger one will be put here. So maximum of order log S or log R. Agreed? Now they come to this part. This is the sequential merge. You have to know the size of this. Now and you are looking for every even index V. So once I considered V means that there are 2 index I am skipping, then next one, next 2, and so on, because every even index component I am taking into account. So this is one in V part, this is another V part, 2, 2, 2, such type of thing, so that you get n groups. Now what happens to each group first? Then you multiply by 2 to get the maximum worst case size, right? That in order to get the worst case size, first you obtain this size, then you obtain this size. Now in order to obtain this size, what happens? Because what happens is you will be mapping this element onto this on the original sequence. Now suppose this element is equal to this element. suppose this element is equal to one element here, that means I am on this place, on this image, there are R by S elements will be smaller than or equal to these elements. This point is representing R by S element, because instead of R by S elements you have taken one element here. Agreed or not? You have divided this into R by N, each of size, and you have taken R by nth element here. Now if you find that this element is equal to one element here, what does it imply? That R by n elements will be smaller than this element. Yes?
Yes.
So similarly is the case with S by n elements of this. Because this point is representing S by n representation. So worst case size is R plus S by n, because R by n plus S by n. Similarly R by n S by n, because it is a 2V. So it is, size is 2 times R plus S by n is the merging element, total number of elements to be merged in the worst case. So which cost is order this, because this is a sequential merge. So if I add all these things, the time complexity becomes TRS is equals to order log n plus order log R plus order log x plus maximum of this is more maximum. Order log n plus maximum of log R log S order R plus S by n. So this is the time complexity you will be getting, and cost now, if R equals to S equals to N, this cost becomes so it is cost optimal if this is order n, right? This is cost optimal if this is order n, because merging of two sequence of size n takes order n time. So this is cost optimal if order n log n is of order n. It implies n is less than or equals to tell me 8 elements in sorted order.
7, 5.
7?
7, 5.
Sorted order.
Sorted order. What is the 6?
No, there are two sequences I have to. I want to merge it. One is how many? One is 8 element, another I take 12 elements. Right? To understand the algorithm. Tell me. Quick. 1,
6,
6,
7,
7.
8,
Next.
10,
10.
12, 15,
And
18,
tell me. 2, 3. Then
4,
no. Right? Let us assume this. So you have R equals to 8, S equals to 10, and let us assume N equals to what? Hmm? 4? So initially you have A dash sequence and B dash sequence. What is your A dash sequence? In A dash, how many elements will be there? 2. Which are those 2?
6, 8.
Huh?
A dash would be 4 elements. 8 by 2 elements. 2 elements. 2 elements.
Why 2?
4 elements.
3 elements, huh? You will be getting n minus 1 points. 3 elements. So which are those 3 elements?
7.
Use check your notebook. Step 1.
6, 10, 15.
Huh?
6, 10,
6, 10.
15.
What about B? 10 divided by 4. So 2. So 2 into 2 first is 4th element, right? What I will write here? 3, 13, 23, 24. Yes, by, so you multiply 2, 2, 2. 13 will be there or not? No.
No, sir. 11.
11. Okay. Then 17. Right? Now you got next step is your to compute V. 3. Index is 1 and it is belonging to B. 6. Index is 1 belonging to A. 10. Index is 2 belonging to A. 11. Index is 2 belonging to B. 15. Index is 3 belonging to A. 17. Index is belonging to B. This is your B. Right? Then you have to obtain Q. 1, 1. So first you will be checking this one. B2I minus 2. The processor 1 is checking this one. Processor 2 is checking this one. It is belonging to A sequence. And 1. So what I will write here? 1 into 1 into R by N, which is 2. Agree? And now you will be, after multiplication I got 2. Now you will be checking that the number of elements, the element which is larger than, smallest element larger than this, which is 8. Position of 8 is 3. Then in the meantime, simultaneously, the processor 3 will be looking for this one, right, which is 11, and 2 means 4, and the sequence A, 1, 2, 3, 4, 5, so you will be writing 5, and simultaneously this will come, sequence B, so it is 6 and 17, 1, 2, 3, 4, 5, 6, 7. This is your Q sequence. The first processor will be, first processor searching zone will be 1, 1, 1, 1 to 2, 3. Now 2, 3 will be 5, 5 is here, so 5, 4, 2, 3, Q is this, until it covers this, and then 2, 3 is this one. It starts up to 5, 4, 5 is here, and 4 is 11, 5, 4, and then 5, 4 goes up to 7, 6. 7 is here, and 6. 1, 2, 3, 4, 5, 6. So this is the structure you will be dividing this, and the processor P1 does the merging of this, P2 does the merging of this, P3 does the merging of this, and P4 does the merging of this, right?
Simultaneously, all the processors are reading, writing.
Where I am writing simultaneously? See, first step, is there any simultaneous read anything? In this step, that obtaining Q, is there any simultaneous read or a concurrent read? What are the steps? What are the steps I did actually? Tell me. This is completely based on sequential merge, allocated area. Every part is doing, every processor is doing sequential merge. That can be done independently because I know the starting index, I know the end index, and binary search. Now, in the case of binary search, every processor is taking B sequence, taking A sequence, so there is a possibility that concurrent read, middle element will be read by several processors, right? So due to that you need concurrent read and exclusive, but there is no question of exclusive concurrent write. You see that they are being done, write part is being done independently in distinct area. So exclusive write is okay. Concurrent read is due to the binary search. Okay, now if you can get rid of that concurrent read for binary search, then this can be implemented on EREW model. Now as you know that through broadcast you can get rid of it, right? which for that you have to pay log n additional time. So the time complexity will be increased by log n factor here. So multiplied by log n will become. So then it will be increased like anything. You will not be able to achieve the cost optimal algorithms, right? Now, but one problem, if you observe that what we tried, we wanted to divide the sequence into such a way that estimated size of the subsequence is order R by S plus divided by N, so that every processor is equally busy to give you the sorted sequence, right? But in reality, as you observe in this example, that in the last case you have seen that the number is not exactly R by S, R plus S divided by N, it is much more than that. Okay? So that part has to be taken into account cleverly, because here you have taken R by N or S by N, S is 10 divided by 4, so it is coming 2.5, and you have taken 2 every time. So alternatively, if I take 2 and then 3, 3 possibly, you will be able to distribute it more efficiently and more equally. But in the case of EREW model, this may be a little difficult to do that type of manipulation. So the idea in EREW model is little different. What we are doing or planning to do is that we want to divide into 2 equal parts. Now, how to divide into 2 equal parts? That if I can find out the median, right? Median of these 2 sequences. So, suppose this is the median of these 2 sequences, means there will be one element here, there will be another element here, right? So this is AX and this is BY. By some method, I divide into the 2 parts so that AX, BY, one of them is median, and the other one is the neighboring element of the median. Maybe the smallest element larger than this, or largest element smaller than this. Next, you divide this into 4 parts, right? Using the 2 processor. Next time using 4 processor, this is one block, another block, another block, another block. You find the middle of this and so on. In that case, you observe that after log n steps, you are dividing this whole sequence into n equal subgroups. Agreed or not? Say you, yes?
Yes.
So you will be getting the n equal subgroups, and then sequentially you merge it, right? So to do that, first you have to define median pair, because exactly finding median, say if I have the 2 sequences A and B, and you want to find exactly a median, it will take a lot of time, because there is a question of merging and then find the middle element and so on. Instead of doing that, we are finding a median pair AX, BY, and if AX is median, it means there exists precisely or exactly if Ax is median, then there exists precisely m by 2 minus 1 elements in A dot B smaller than Ax and precisely m by 2 elements in A dot B larger than. Similarly, is the reverse one if By is median. If By is median. Right? Now, what is your By if Ax is median? In the median pair, what is the role of By? What is the By? So, By, if Ax is median, then By is the largest element in B, smaller than Ax, or the smallest element in B larger than. If Ax is the median, then By is the, so suppose this. So if Ax and By, now the By is either just larger than Ax or just smaller than Ax, right? Now that may be so happen that in your program we'll be able to produce the two median pair. One is Ax By, another one is Ax dash By dash. Right? If it is the case, then you have to select one of them, right? So one strategy you have to follow, that you will be selecting the one whose indices is smaller than the other one. Right? Sum of the index is smaller than the sum of the other indices. Right? Then that will be your median pair, because you cannot handle two median pairs for your work. So if your algorithm generates more than one median pair, then you select the one whose sum of indices is the least. Right?
Why aren't we finding out the exact median?
How can you find, tell me?
This is the sorted sequence.
Yes, I have one sorted sequence. You have another sorted sequence. This size is R, this size is S. Now tell me. Let's understand.
So the middle element?
This middle element you got this one, and middle element this you got this one. Then
recursively we'll be dividing both.
no, how? Tell me a little. Give me. I got it. This is the initial Ax, By. Then
now we have to merge these two.
you want to merge these two?
Yeah. Finally, but now currently we will be recursively dividing it
Dividing into?
into two parts. So finding.
Achha, you want to divide this one, then this one like this?
Yeah.
Oh, that. See, now the scenario is, if you do this way, where you will be problem? Let us consider one example: 3, 4, 5, 6, 7, 8, and here 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Now tell me your strategy.
3, 4, 5.
So you want the median. Suppose this is the median. And 1, 2, 3, 4, 5, 6, 7, 8, 9. So fifth one is your median. So first you divided this one. Then second, this. And suppose 10 you have divided. Similarly, you have divided 7 and 17. Now, you want to merge this.
Yeah.
So you get 3, 10, 12. You get 4, 5, 13, 14, 6, 7, 15, 16, maybe 8, 17, 18, 19. Then, so the idea is not only to divide, this and then recursively this and this in such a way that all these elements will be larger than this element. That is the reason why we are looking for median, right? All these elements, not only equal parts, but also this element is larger than this element is larger than this element, and so on. Right? That is the idea of median pair. Clear? If you have Ax, By is a median pair, if it is the median pair, and let us assume that this is your median. Suppose Ax is median, right? Then can I draw this conclusion that x plus y minus 1 is precisely Ax is median and x plus y minus 1 m by 2 minus 1, agree? Because the x is the index, y is the index for the B. That tells you that many elements are either smaller than this. So this is the exact location, or precisely x plus y minus 1 is equals to, or m minus m, or whatever. What is m? M is the number of elements, number of R pluses. So m minus x plus y minus 1 is your m by 2. Right? That is the precisely that many elements from the other side will be larger than this element. Right? Either that many elements smaller than this, or precisely that many elements are larger than this. These are just from the definition. I am not writing anything additional. Similarly, the case with By, if By is the median and other things.
So these two numbers could be from the same sequence.
Which one?
So Ax and B.
No. Our target.
But Ax is the median. So suppose the median lies in the B sequence.
Tell me. Let me understand your problem. Now, tell me.
If Ax is the median.
Ax is an element in A, By is an element in B, and one of them is median. Other one is the either largest element smaller than B or smallest element larger than By. Right? It can be this one, it can be this one, not this one. If this is here, then this will be here, and so on. Or if, but this cannot be median. Can it be? Huh? Can it be median? If it is median, why it cannot be median?
If this has more elements than it can be.
More than these elements, it cannot be median. Right? So those properties, I think you can analyze through your analytical ability. But lot of good properties exist on median pair. So you can try and think whether this can be used for you in your term paper to do something else. Tell me 4 elements of some sorted 4 elements, 4, 6, 9, 12. And this side, 1, 6 elements, huh? 5, 7, 10, 30. How many elements are here? 15. Which is the median here? first one is if 7, so 7 is possibility 6, 7, then 9, 7. Now if it is 9, 9, 10. So these are the 3 values can be possible candidate for your median pairs, right? So you will be selecting the one. So this is index is 2, 3, index is 3, 3, and this index is 3, 4. You will be selecting the one which is the minimum one. So 6, 7, you will get the median pair. With the understanding that 7 is the median.